All right, welcome back. For those of you just joining, my name is Magnus Bäck. I work with CI tooling and other tooling at Access Communications, and I'm going to have a rather short talk about event SDKs. So what do we even mean by that? It's a relevant question since we don't really have any proper event SDKs in the ecosystem right now. So what we mean by that, it's a library for a particular language that allows us to work with Eiffel events of any type, any version as high-level data structures. We want to be able to serialize such data structures, such values to JSON, have them validated, so we're not sending out garbage. And just as important, also deserialize arbitrary JSON strings back into high-level data structures. Well, arbitrary JSON strings representing valid events, of course. And the reason we want to have these is that it's simply much easier for both consumers and producers of events to have proper data types for Eiffel events. This is especially true when working in typed languages. If you're working in Ruby or Java, sure, you can assemble dictionaries and arrays easily, but in typed languages that gets a lot more cumbersome, which we'll see a short example of in the next slide. It's also, I think, especially true when consuming events. It's my experience that piecing together in especially typed languages, piecing together some kind of dictionary or map that would represent an Eiffel event, that's pretty easy when you're creating it. But doing it the other way and extracting values from just an anonymous map gets really boring with lots of null checks and type conversion, everything. So just checking a single value from such a structure might sometimes, depending on the language, require 5 or 10 lines of code. And that just creates very unmaintainable and not very nice code. Same thing with writing tests. Usually, I would say your test would be a lot about creating test events as inputs or interpreting events produced by the pipeline actor. And if you don't have a sane way of interacting with such events, your tests are also going to look really bad. Having an SDK also means that there's no issue with typos of member names. You can have support for auto-completion and so on in your IDE, linters and so on. This affects all languages, of course. So these are just 2 short examples in Java and Go, what it could look like if you don't have proper data types for assembling a very, very minimal event that only contains the meta.type and meta.id values. In this case, I actually think that the Go code looks a lot cleaner, but it's still not that nice. The Java code is pretty awful. And as I said, this is for creating objects. Going the other direction would be way worse. I didn't bother putting together such an example. So you might think that you've seen classes or other data types for this in various places, and it's true. Various Eiffel community repositories contain code for this, but it's limited in different ways. Eiffel RemRem Semantics has this for Java. It certainly works for producing JSON. I'm not sure about deserializing JSON strings into these data structures. Quite possibly works. I'm not sure it's used though, but it doesn't support different versions. It only has a single exact version down to the patch level is the only thing supported. So while you could use it for producing events, you would not be able to use it for going in the other direction in the consumer end. We have Eiffel Python lib, which of course is for Python. It supports both directions, to and from JSON. Again, it's not versioned. I'm not sure exactly what happens if you would deserialize something of the wrong version, but it might work. But on the other hand, you won't get any typed data structures. So while you would get events with the data, meta, and links members nicely typed in the object, the contents of meta and data are still just anonymous dictionaries. So there's still a bit of a pain to work with, and you won't get ID support and so on. The Eiffel Broadcaster plugin that I talked about a few minutes ago has support for both directions. Again, it's not versioned. I'm not sure what it would happen if you would have to deserialize something of the wrong version. And it only covers few events, the activity events and artifact events. Handwritten code, but yeah, it's not enough. Access a Gerrit plugin, basically the same situation, a number of handwritten classes that would work in both directions, but it's not versioned. So it's not universally useful. So it seems like since there's nothing generic for this, every time people start working on a producer or consumer, they start building stuff of their own. They feel either they don't know about the existing options, or they feel that they are somehow ill-equipped or not good enough for their purposes. Or it could be a question of dependencies. RemRem Semantics has quite a few dependencies. And one of the reasons I didn't include it in Eiffel Broadcaster was because of these dependencies. I didn't want them to clash with the other Jenkins dependencies. So an interesting property of a good SDK would be that it doesn't include the whole kitchen sink. Maybe the validation part should even be optional, so you don't need to drag in validation libraries, perhaps. I mean, ideally, it's just a matter of having data types representing JSON objects. So as long as you have JSON serialization, deserialization, you shouldn't need to have that many other dependencies. Now, one of the bigger challenges here is event versioning. And this is why creating data structures for producing events is so much easier, because you can just pick your version and stick to it. And you would probably go with the most recent version of every event. But when consuming events, you don't have that luxury. You get the event you get on the bus, and you have to be able to deserialize it into something useful. So quite obviously, we need separate types for every major version. Probably no way around that, because theoretically, one member could change data type between two major versions. That would probably not be a great idea to change the type like that, but it could happen. So it obviously wouldn't be compatible. However, I suspect we'll be able to reuse the same type within a major version. In other words, we could have the same high-level data type for all V3 events, for example. And the type for the V3 type would then include the most recent, the members from the most recent version of that event. And in other words, so if 3.1.0 introduces a member that we represent in the data structure, and we deserialize a 3.0.0 event that doesn't have that member, the member added in 3.1.0 would be empty or null, or get some kind of sensible default value, so that if we again serialize that same data structure, we would get back the 3.0.0 event that we used as input before. That should be possible. We could, of course, have distinct types for every minor and every patch version of every event, but that would result in a fair amount of clutter. We would have hundreds of classes or structs or whatever is applicable in the language in question. Quite a bit of noise when upgrading client code to support a new version. But we would also probably, depending on the language and what the language supports, probably have issues with type equality, type assignment. You would, yeah, I don't have a concrete example, but you could have functions or methods accepting, let's say, a meta structure from an Eiffel event. And if that meta structure is different for every single event, you might have a problem writing such a generic function, for example. Again, depending on the language. So the code here at the bottom shows what it perhaps could look like. At least for the top level event, you would have an Eiffel artifact created event v2 and a v3. And then there are many different design choices on how to deal with the data members. Would you have, in the Java case, an inner class containing those fields, or would you have it at a separate class named Eiffel artifact created event data v2, for example? Probably doesn't matter that much, but those are considerations you have to make. Also depends on the languages. Java has inner classes, other languages don't. So other challenges. We have JSON schemas for all events, of course. So it's very tempting to generate code for the data structures. Unfortunately, the API of that code could be pretty disappointing and might not represent the canonical way of writing code in that language. You could have names that would be not great. The code itself could look like garbage. That doesn't really matter because it's auto-generated code. But similar to when you're working with, let's say, parser generators and that kind of auto-generated code, you could get interfaces that are pretty quirky to work with. One example would be from rem semantics, where the meta.version member isn't a string as you might expect it to be. Instead, it's a type, an enum type, with a single valid value, namely a string representing the version supported. And this is, in a way, technically it's totally correct because that's what the schema says. But it doesn't make intuitive sense, and it's not great to work with. And it of course totally would prevent what I just suggested in the previous slide, namely that we have the same classes or structs for all the event versions within the same major versions. But we can't do that if the generated code only allows exactly one version value in its field. So generating the code could be tricky. Handwriting the code, of course, you can get any interface you want, but it can grow pretty tedious, especially if you want to make, well, you have to support all past versions of events, so you can't just go with the most recent events. The event definitions, you have to at least go reasonably far in the past. And if you want to make structural changes, if you figure out how to do something more efficiently, or I don't know, that would be pretty boring to update all the 23 events times 5 versions or something. So that's not a great situation either. The best solution might be depending on what language you're using and the tooling available for doing this. So I was hoping to have a Go SDK to show today. Unfortunately, I haven't had time to work on that. Work has started though, and it'll eventually get published in the Eiffel Events SDK Go repository. As you can see from the repository name, we have include Eiffel events in the name to signal that we might want to support other kinds of SDKs. For example, we might want to have SDKs for talking to event repositories or interactive publishing events via RemRem. That might make sense. And we also, of course, want to support many different languages. And we thought it would make sense to have one repository for each language. I suspect at least the Go SDK will either contain handwritten types or types generated from the schemas with a custom program, as opposed to some other languages. Go ecosystem has a pretty strong culture of writing programs that generate Go code. So since the Eiffel schemas don't use the whole wide range of what you can put in JSON schemas, you would only have to support a limited set of what's actually in use. The benefit of using that method is that you can handle what I talked about earlier, that RemRem has a problem with, sort of quirks like members that really are strings, but they might be implemented in the schemas as something other than plain strings. Or this might be a signal that we perhaps should change those quirks in the schemas instead for the benefit of being able to generate code. But that's another question for another day. And that was it. Any questions or comments?
Yes. Can you hear me, by the way? I'm not sure if this mic works.
Yeah.
Good. Yeah, I have. This is sort of my favorite topics. I have loads of questions, but I'll take them one at a time to not spam the whole session. So you mentioned having different types for different versions of the events. For client code to be able to use this in a good way, I think it would make sense to also have base interfaces for the different versions of the same event, because they will be mostly similar, like 98% similar or 95% similar. So you shouldn't need to have to write like different methods for handling different versions of events. And it would make sense that if we write SDKs in different languages, then we try to align on the same or similar base interfaces for these events. Is that, or does that make sense? And
that makes total sense, and that's actually one of the reasons that I wanted to bring it up here, to sort of create some kind of awareness around the problem and make sure that we perhaps get some kind of alignment. It's and I also totally agree about the interfaces. It could be how you actually do that would depend, I think, a little bit on the language. That would be very natural for Java, for example, where you always have setters and getters, while for Go code, where you would access the struct members directly, that wouldn't work quite as well. So a little bit language dependent, I think. And of course, Python doesn't really have interfaces. So, but if possible, yes, I totally agree.
Because then it would be great to start some sort of some sort of discussion, or maybe some sort of small work group or something to see if we can align. And I mean, these interfaces, they don't have to be just actual programming interfaces. It could also be a way we look at our events to say what do we have. I know one discussion that was up as well was that like the meta object is, I think, identical across all events, but the way it's specified, it's actually per event type. So yes, that is one example of event that we could look into. I should mention that Dual is writing a .NET SDK for this. So I think probably you and I should talk at some point, so we can make ours as similar as possible to your Go SDK.
Yes,
that
please.
Would be great.
Yeah. That's you're really great comments. Let's see. What did you say before the .NET SDK? Was something I wanted to comment.
No, there was the meta interface.
Yes. There will be a discussion. I think it's the last session actually today at 3 p.m. European time about whether we should extract such common substructures from the events like meta into separate schemas so that they can be shared amongst all events. Because as you say, in practice, at least within an Eiffel edition, the contents of meta is exactly the same. And making updates is a huge pain because you have to modify 23 schema files. And it also creates problems, just like the enum type for the meta.version. It creates problems when you want to generate code, because then suddenly you have one meta class or similar for every single event, even though it's really exactly the same. And then you can't necessarily easily compare two such values, for example. But yeah, it's definitely sounds like we should be talking.
Yes, I had another question, not necessarily to you, but if I don't remember wrong, then it's not the case that every version of the specification introduces new versions of every event, which means that as a user, I will have to send to like be on the latest version of the spec. I will have to send different versions of different events, and this is going to be hard for me to know what versions of event I should send. So we were sort of thinking or wondering, should we have like namespaces for different versions, and then you can reuse the same type in different namespaces and not bother so much about versioning individual events. But yeah, this is a tricky subject. Have you thought anything about that?
No, I'm afraid not. So you basically, instead of working with, version 1.2.3, you would say that this is version Paris of this event or something like that.
Yes, so it could be something like you have a namespace events.paris.Eiffel activity triggered event, or events.toulouse.Eiffel activity triggered event. And it might be that those are actually identical in different editions, but as a user, I just need to know, okay, I will only use things from the Paris namespace, and then I know I'm sending consistent versions across my application.
Right, so that would be more of a JSON schema namespace thing, which wouldn't necessarily affect the schema, the leaf schema files, so to speak.
That is probably true, yes. So it would be a way for me as a user of this SDK to understand what versions I need to use to be consistent, or to consistently use the same specification version or edition.
Yeah, that probably makes sense. On the other hand, clients need to be able to consume any version. So it probably makes sense. Yeah.
And that what you just said brings me very nicely to my next question. So is it the case that as a client of Eiffel, or as a receiver of Eiffel messages, I need to support every version of the protocol? Because I believe, and that goes for the SDK as well, like how old versions should we support when we release this SDK? Should we go all the way to the beginning of Eiffel's history, or can we just select a few of the more recent versions? What should our strategy be there?
Yeah, that's a good question. I don't believe that has been discussed. I mean, theoretically, all versions. In practice, no, because I don't think there's any software in use that doesn't support at least the Argent -1 release, for example. I don't think anyone's going to be sending any Toulouse events anytime soon. But that's also, I guess, a question for the organization. I mean, for us, we definitely don't send anything older than Argent, and hardly older than Paris either. And someone starting right now would have no reason to send anything but Paris, for example. So as long as we don't pass events between different organizations, that could be a local convention. But of course, it does affect if we have a community SDK. But I mean, it could just like we're, sort of like LTS releases, we drop support for certain old stuff. We could say in the SDK that no, we won't support anything older than Agen 1 or Paris. And if you're using something older, sorry, you have to upgrade your producers and consumers, for example. I think that would be a reasonable policy.
Yeah, because I mean, we are probably going for the hand-typed classes and interfaces, so it would be a lot of additional work for us for no additional value for us to implement a bunch of old versions. But of course, I mean, since this, as you said, it would be a community SDK, then if someone wanted to have support for an older version and we have the sort of design patterns up for adding an old version, then they could just contribute that if they want to, and that would be fine.
Yeah, definitely. That makes total sense.
Yeah, I think that was all I had. Thanks. As I said, I really enjoyed this topic.
All right, thank you. Thanks for the great questions.
I totally agree there as well. I can just fill in then, of course, that if we talk about the SDKs, maybe dropping support for old versions, of course, that's true for all consumers of events as well. So any tool that is an event consumer, then we will need to state what versions of the spec do we support in those tools. And so it's the same there, of course. And we should maybe have a synced life cycle or something, or time to live on our event schemas or event editions throughout the different consumers, including SDKs, which is in some sense a consumer as well. Yep.
And it does connect back, Emil, I think you mentioned yesterday that you see a future where we make more releases per year of the protocol. And that will, of course, mean a little bit more work per year for the SDKs as well. So that somehow, ideally, when a protocol version is released, the SDK should already be in place to use that new version. And that's something to consider as well.
Sure. I guess that was mostly my personal thoughts, that I think we will release more versions, at least 2 per year, but it's nothing we have set anywhere or decided anywhere. It's just
but it makes sense, and it will provide for faster evolution, which is nice. But
maybe we shouldn't be limited by very few releases per year. At least if we need more, we should have more.